Chorus, flanger, and phaser are all based on time delay. So delaying the copy of the signal and adding that to the original. Now with the phaser, it's really small. So that movement, that time delay is so small that it's actually just moving the phase of the signal a tiny bit. Now that's in samples, not even in milliseconds. And moving the phase of a certain portion of the frequency spectrum gives us that frequency cancellation in form of those notches that we already seen in the sound design lesson. So let me show you the phaser as it is like this in an effect. So let's try this phaser out on this synthesizer right here. Let me play that for you. Now with the phaser. And I should also most probably show you what that looks like on the actual spectrum analyzer, just like this. Let's see that. So you can see those notches moving left and right. Now, the more poles we have, the more of those notches we produce. Now in this phaser, along with the poles, and meaning how many notches we are going to produce, those notch filters, we also have two modes, earth and space. And in this phaser, it just makes a different order and spacing between those notches. And in the earth setting, we can further, set the timbre of the phaser using this color knob. Of course, we have the dry-wet setting. So with adding the wet, we are actually adding that notching, adding that phaser into the signal so that we get those notches right there. We also have this XY graph right here where we can set up the feedback and the frequency where the notches are initially, like this. Of course, I have this envelope follower where we can follow the actual transients of the sound and react to that, or we have the LFO. So we can turn that LFO off, and now the phaser is just going to produce those notches and not even move, like this. You see that always in the same space, always in the same spots. Now I can move those, moving this frequency. So that means that I can actually move the phaser with my hand like this. It doesn't actually have to move using an LFO and always have a static, movement up and down. I can actually move it myself. That's it, and I can make the LFO move it around the center frequency. And we have the envelope follower, which can react as an envelope to the audio input. Maybe even faster. Many interesting things that we can do with the phaser, but the entire effect is made up of all those notches that we have that are produced and that are moving left and right. You see how many notches? And that's really nice. Now we can introduce some movement to that synth. Now we also have that same phaser effect inside the synthesizer itself. Let's see that, like this. So in the FX section, we also have that phaser. Let's try it out. Nice. Sounds really nice and adds some movement to this chord. So let's hear that in the context of a song without the phaser and with. Adds a really nice effect, I would say. Let's see about the flanger. So the flanger, also by adding another copy of the signal, delaying it, and then also adding vibrato. So adding a movement to that delay. Adds that really, recognizable flanging effect where you have that hissing of the high frequency. So a flanger also nice to add movement. See without it. Of course, I would add some EQ on top of this and just lower down those high frequencies because I think adding a flanger just adds a lot of those, but that is just a subjective opinion of mine and how this actual instrument fits inside of this song. But you can see that without any of these effects, now this chord is really nice and this instrument is nice, but when adding that flanger or a phaser, adds some nice movement and makes the sound interesting and evolving. If this pattern was actually to repeat itself over and over and over, this flanging or phasing would actually add some nice and interesting movement to the sound. Now in depth on this flanger, we also have a high pass filter where we can high pass out the low frequencies because they don't really sound as well on a flanger. Just adding a copy of the signal in the low frequencies just tends to easily cancel out the lows, and that doesn't really produce any flanging. So it's more prominent in the mids and high frequencies. We also have the dry wet, we have the delay time for the flanger, of course, and we have the feedback. So how many times that repeated signal, that copy of the signal is going to repeat again and again. This is how we get all that hissing, all that feedback, you see, because without it, see, without the feedback and with, really nice. Now we can also make that movement by ourselves, the delay time movement, but we can also move it using an LFO or an envelope follower that is included right here. Now this feedback can be reversed in polarity, so we can choose that feedback to be in plus polarity. It's a good thing to know that this actually changes the polarity of the feedback, but just making it sound right is a thing of experimentation, depending on the sound, depending on the context of the song, actually. Now, when talking about both of these, the phaser and the flanger in Ableton, you can see that they both have this XY pad right there where we can move two parameters at once, just like this. So the upper one, the Y-axis, up and down, is actually the feedback. So you can see that like this. And the X-axis is the frequency. Same here, the delay time is the X-axis and the feedback is the Y-axis, up and down. Now to induce movement in this delay time, we can use the LFO, as I've said, or the envelope. Now, how do we get this envelope and LFO? Well, so far when I explained these to you, they usually had, the envelope at least, had something to do the envelope at least had something to do with the MIDI. So with the MIDI messages coming in. Now we don't have any MIDI messages, but this envelope follower actually reacts to the absence and presence of audio. So every time we have an audio start abruptly, we have some abrupt change in the audio amplitude. it would consider that as a MIDI message of the envelope to start. So this is actually an envelope, but it's triggered by a sudden change in the amplitude of audio. So once the audio gets louder really suddenly, that would be a trigger for this envelope to happen. And that envelope can control, of course, the frequency right here and the delay time right here. Also, we have the LFO, and the LFO has different shapes, as you can see that. So we have the LFO, the low frequency oscillator, that can be a sine wave, a square, triangle, sawtooth, positive, negative, and a random one. So this is the randomizer, sample and hold oscillator that we are using for this LFO. Now, also this LFO, in both of these cases, as you can see, can be synced to the musical timing, musical divisions. And we also have the phase for both of these. So the phase between the left and the right channel in here. So let's try that with the phaser. Let me show you what it sounds like. Now this phase actually affects the LFO. So this is the phase for the LFO oscillators, meaning that at 180 they are perfectly out of phase, meaning that there is two LFOs for the left and the right channel, and they are perfectly out of phase when this is at 180. Same here for the flanger. We have the envelope, the LFO, and on the LFO we have the phase. Now another thing we can do in both of these is we can offset the starting point for that LFO. So as you see, this is a sine wave. It would start from 0, go up, and then go down, go back into 0. That would be one oscillation. Now we can offset where this LFO is going to start from. So if I go to 180, it's again going to start from 0, but going downwards. See, at the half of this actual oscillation. So we can even offset where the LFO is going to start from every time it starts. Now those are about all the controls that you have in the phaser and the flanger. Now let's check out the chorus on this synth. Now without, and with the chorus. See that? It also has a high-pass filter integrated so that we can cut off the low frequencies so we don't chorus those out. So it removes all the frequencies from that delayed signal that we are introducing so that we don't get any phase cancellation in the low frequencies. And we will talk about why we don't want that more in the mixing and mastering course. Now we have two delays inside of this chorus, meaning that we are actually producing two voices added on top of the original one. And we also have the feedback and we have the polarity for that feedback. Now this delay can be fixed to this one, of course, and can be modulated, of course. You see, a lot. And it can be turned off. The second delay, of course, can be turned off. Now we have only the first one. So what are we introducing with this? We have the amount, that's the delay, of course, the delay of this voice in milliseconds. And this is the modulation part, of course. How much are we modulating? So this is like an LFO. How far from this value in milliseconds? And this is the rate, how fast we are modulating. See, it can be really fast. So we can do really fast with a small amount. Nice. And also we can do the second delay too. So what we have in a chorus is two added on copies of the original, each one delayed by its own time, and then around this center point where we have it at 4.67 milliseconds and 17.3, we are adding this much more or less delay. So we are oscillating around these points right there this fast. That's it. So we are oscillating this value and this value around the center value where we just fixed them, this much, up and down, and at this speed. Now we also have the feedback, meaning that we can introduce a feedback loop into this chorus as well as we could right there into flanger, into the phaser. And when introducing the feedback, we get that hissing. See, almost like a really fast delay sound. Of course, we can change the polarity of those feedback signals that we're sending. This is how we get a nice chorus being subtle. Just like that. Now without it. And this chorus effect was really popular in the 80s. They used to put this on everything, on the vocals, on the guitars, on the drums. And yeah, it just broke through. But it's a really nice effect, adding kind of like a chorus, what it would actually mean, like a choir. So adding more voices to the original voice and making those other voices different would be by, you see, delaying them and modulating that delay amount. So it's giving us a nice, lush and rich sound by adding chorus. See? And in the context of the whole song, of course, by adding that chorus on top and applying this high pass, we're actually adding more of the high frequency content above right here for 100 Hertz. But we can always adjust to that by using an EQ after it. Usually you want that addition, and by using a chorus, you do add some brightness to the sound. You also do muffle it a tiny bit because there is kind of a phase cancellation happening by having these voices, added on top of the original and then modulated. But the actual sound is what matters. So by just trying it out, you can see if that actually fits your song and the concept of that one instrument or a sound or not. Of course, you can use these three effects without knowing anything about them. So just by applying one of those to the sound, seeing if you like it, and that will be it. The reason I actually learned what, let's say, a flanger was is back in the days when I used to make music in DOS, like Windows was really bad. It was 3.11 or something. It looked really bad and wasn't so much in use already. So I used to make music in DOS, in a DOS-based program called a tracker. All of those programs were called trackers. You had those on Amiga computers. The same. So now the way I used to get a flanger in that program was by actually copying a sound, delaying it just a tiny bit in milliseconds and applying some vibrato to it. Because those programs were only using audio, there was no MIDI or synthesizer, so I just used audio samples. But this is the way I learned how to make a flanger and what flanger actually is. Now I'm going to show you how you can improve the sound of your song by using these effects along with the delays in the practical portion of this level.